Hello, everybody. In this video, we're looking at questions 6 and 7, and we're following along paper 2, which is the DBE November 2023 exam paper. So if you've been following along in the videos, you know that this section of those questions covers the trigonometric functions and the graphs, and then it looks at 3D trig. And so what we're going to do is basically answer all of these questions step by step with you, and then you can hopefully do better in your exams. So here's question 6. What I also suggest maybe doing is, if you haven't, try the question first and then watch how to do the solution, as that will help you figure out where you went wrong, and it's a much better way to practice your maths. Okay. So in the diagram, you have the graphs of f of x, which is this one here, is equal to 2 sine 2x, and you have g of x is equal to negative cos x plus 45. That's this one here. You can see it's shifted over from where it should be. And they're drawn for the interval x is an element of 0 and 180. So from the point 0 to 180 degrees precisely. Okay, so A is the point 105 and negative 1, and it lies on the graph of f. So the first question says, write down the period of f. And if we go back and we look, the period is how long it takes to complete one graph. And we can see for the sine graph that that is between 0 and 180. So the period of the graph is 180 degrees. And then you'll get 1 mark for that. Okay. Then it says, determine the range of g in the interval of x is an element of 0 and 180 degrees. So if we look at g, we can see it starts here at some point on 0, and it goes up to some midpoint there, 135, and it comes back down. So we need to find the minimum and maximum of this graph in order to find the range. Okay, so if we substitute 0 into cos, so we'll have g of 0 is equal to negative cos 0 plus 45 degrees. That will give us negative square root 2 over 2. Okay, and if we do the same thing for 135, and to find this, we're just going to chuck it in the calculator. I'll show you how to do that in a second, just so that you know. So it's negative cos 135 plus 45. And that gives us an answer of 1. Okay, so let's get our calculator quickly, and I'll share that with you. So if we were doing the 0, it would be negative cos, open brackets, 0 plus 45, close your brackets, equals, and that gives us the 1 point. And then if we just want to do this quickly and put in 135, then we get 1. Okay, so that's how, so that isn't really the final solution. What you now need to do is then write down the range. So you're going to have negative square root 2 over 2 is less than or equal to y, which is less than or equal to 1. So between negative square root 2 over 2 and 1. All right. Now, the next question says, determine the values of x in the interval. X is between 0 and 180, and we can just see that by looking at the graph. So the first one says, f of x multiplied by g of x is greater than 0. And the way that we find this is the only way to get greater than 0 is to have a positive times a positive, or a negative times a negative, right? That's the only way to make greater than 0 means positive, okay? So the only way to make something positive is to multiply by the same signs. In other words, they must both be above the x-axis or both be below the x-axis. So now if we go back and we look at our picture quickly, we'll see that they're both above the x-axis between 45 and 90 degrees. Okay. And nowhere else. Then the rest of it is either all positive and negative. So this would give us negative values, and this one as well from this direction onwards would give us negative values. So our solution here is going to be between 45 is x. And because there's no equals to, we don't need an equals there. And 90 degrees. Okay. Now, for where is f of x plus 1 less than 0? So again, let's go back up and look at our picture. So where is it? F of x is this graph here, and we need to add 1, and it must still be less than 0. So anything between underneath this line is going to be where we can have it less than or equal to 0 if we push it up by 1, right? Or it will remain less than 0 even if we add 1. So that's going to be the point A is 105. And then we need to find this other point here. Okay. And what we can do is just mirror that. So from 105 to 135 is an extra 30. Okay, and it's going to be mirrored. So it's going to be another 30 on this side. So this coordinate will be 165. So our final answer, when we go back to our question, is that it lies between 105 is less than x, less than or equal to x, and less than or equal to 165. Okay, so just 2 marks for those as well. All right. Now, our next question says another graph, P, is defined as P of x is equal to negative f of x. The d of k minus 1 lies on P. Determine the values of k in the interval x is between 0 and 180. So we know that P of x, or we are given that P of x is equal to negative f of x. And we've also been told that f of x is 2 sine 2x, right? Okay, but we don't really need that. We just need to look at our negative 1. So if P of x is equal to negative 1, then f of x will be equal to 1. So where does k of f of x equal to 1 lie? So if we just solve this, so we have f of x is equal to 2 sine 2x is equal to 1. We can now solve for x, okay? So we'll have sine 2x is equal to half, and we take sine using our calculator, and that will give us, 2x is equal to 30 degrees. How do we find it on the calculator? Just briefly, what will happen is you will have inverse, so second function sine, and then half, and equals, and it will give us 30 degrees. Okay, now going back here. So the calculator gave us that 2x is equal to 30. So our reference angle is equal to 15 degrees. Now remember, it's a sine graph, and we can use our cast diagram here. Okay, so sine is positive in this quadrant, which is where our reference angle is. So that will just be x is equal to 15. Sorry, 2x is equal to 30 plus k 360. And our other reference angle will be this one here, which is 180 minus. So it'll be 2x is equal to 180 minus 30 plus k 360. And then we divide everything by 2. So we'll have 2x becomes x, 30 becomes 15, plus k times 180. Now, if we say minus 180, it takes us beyond 0. And if we say plus 180, it takes us beyond our coordinates. So here we just have x is equal to 15 degrees. Okay. Here we've got x is equal to 180 minus 30 is 150. Divided by 2 is 75 degrees. Plus k 360. So when, plus k 180. So when k is 0, we have x is equal to 75. And again, if we make k a positive or negative 1, it takes us outside of the parameters we have been given. So these are the 2 possible values for x that we are looking for. All right, so it's exactly like specific solutions and general solutions that we're using that same methodology on the calculator. In this answer. Right, okay, so The graph H is obtained when G is translated 45 degrees to the left. Determine the equation of H. Write down your answer in its simplest form. And you can see it's just 2 marks, so it shouldn't be too complicated. And what we have is H of X is G of X shifted 45 degrees to the left. And how do we represent that with a sign? Well, when we shift to the left, we are minusing, but because it's minus will take us in that direction, plus will then take us, I know, it feels weird, but when we're shifting a graph, that's actually how we do it. It's the opposite of what our intuition tells us it is. Okay, so here, if we just substitute into g of x, we have negative cos x minus 45, plus 45 was our original graph, and then we add an extra 45 for the shift. Okay, don't forget your degree sign. So we have negative cos is 90 degrees plus x. You can write it either way. I'm writing it this way just so that you can see that this is actually a co-function. And so we have 90 plus x. And if we do our cast diagram, we can see here 90 plus x. This is in second quadrant. And this is a sign, but not a cos positive. So in other words, this is going to be negative. So negative times a negative is a positive. Cos becomes sine. And we just have x because we have reduced it. So h of x is actually just the graph of sine x. Again, it's a theory question. It's being able to apply your knowledge of trigonometry that you have learned through grade 11 work. So pay attention particularly to your grade 11 work, especially for trigonometry. All right, let's move on to question 7. So question 7 says, in the diagram, S, T, and K lie in the same horizontal plane. So if you're using your imagination, think about the room where you're at. Hopefully you have a corner there. And this is the floor that's in gray, colored in gray. Here, I'll color it in for you. This is the floor. And this here is the corner of the wall. And so what they've done is they've taken the corner and they've drawn 2 lines down from that corner to those other points that they have measured, maybe to another corner. We don't know. But the important thing to note here is this is the inner corner of the wall, and you can see there's right angles here on those 2 sides. We don't know what this angle is, and we'll probably have to find it, or it will be given to us later. But in general, you can sort of see and picture the 3D plane that is taking place here. Okay. RS is a vertical tower. The angle of depression, so that's this angle here, is beta. And remember that the angle of depression is an alternating angle. So this angle here will also be beta. Okay, and that's your angle of elevation from K to R. The angle of TSK is alpha, so that's this angle here that we've been given, and TS is given to us as P meters, and the area of triangle TSK is given as Q meters squared. All right, so now that we have all of this information, we've sort of made notes about it on our diagram, we've noticed all of the important stuff. It now says to us, determine the length of SK in terms of PQ and alpha. So if we go back and we look, SK is just the other length of the triangle, and we need to use the information that we have. So we've got P, we've got alpha, and we're looking for this. And we've been given that the area of triangle STK is Q meters squared. And so that's what we're going to do. Also, if you look at the question, it says determine it in terms of P, Q, and alpha, which is a huge clue for what you need to actually use. So remember that the area of a triangle is actually given to you in your formula sheet. But if you are memorizing it, that's awesome. I'm going to write it down here. So the area of a triangle is half. So I'm just going to write down the formula that's given, AB sine C, and we'll then substitute it in based on our information. So we know that the area is Q meters squared, and we have a half. Now, side A, we will just make it P. And side B will make SK. And then remember that the area is the triangle with the included angle, right? So this side 1 included angle, and side 2 is what we're using to find the area of the entire triangle. Okay, so we've got this side, we've got this side that we're looking for, and we've got the included angle, which is sine alpha. So we've used everything that they've actually asked us to use. And now it's just a matter of algebra and simplification. So I'm just going to quickly rewrite this. So I've got P sine alpha. So what I've done is I've just rearranged how I'm multiplying stuff, okay, just to make it easier. So I've got 1 times P times sine alpha, and I'm going to put SK at the back over 2 because it's half. And you can see that's SK. Now we want to get SK by itself. So to get rid of this, we divide by this value. In other words, we multiply by the inverse. So the inverse is 2 over P sine alpha. Can you see that if we multiplied that out, it would all cancel and we'd be left with 1. And what you do to one side, you do to the other side. So our final answer is going to be SK is equal to 2Q over P sine alpha. All right, and that's pretty straightforward for the 2 marks. 1 mark is for substituting in the correct values in the formula, and 1 mark is for actually finding SK in terms of QP and sine alpha. All right. Now, the next question says, show that RS is equal to 2Q tan beta over P sine alpha. Now, if we go back and look at our picture, RS is this long line here, okay? And we've just found SK, and we also know that this angle here, RKS, is beta because it is the angle of elevation. They essentially, if you think about it this way, it's this is a parallel line with this, and we've got that Z shape that's coming through. So this angle here is also beta. Okay, once you see that, you can see that we have plenty of information for what they're asking us for. So let me just clear this away, and then we'll go back to our question. So show that RS is 2Q tan beta over P sine. Okay, so we have a right angle triangle, so it's pretty straightforward. And we obviously going to use tan beta. And tan is opposite over adjacent because you are excellent, are you. Excellent, so it's y over x, okay. And so, or oh, hell, another hour of algebra. Okay, so opposite over adjacent. And if we go back and look at the graph here quickly, you can see if this is beta, then that is the opposite, and this is the adjacent. Okay. Let me quickly erase that. Opposite, adjacent, blah, blah. All right, let's go back to our question. Okay, so we've got tan beta is equal to, and now we can say that it is, okay, so we've got opposite over adjacent. So opposite would be the RS, and adjacent would be SK. Now we already know that SK because we found it previously in the previous question. If you didn't find it, you couldn't prove what they were asking you to prove, then just assume something. And then just say, assuming that, and then use your sort of, this as a guide, therefore, and then continue with the question. Okay. All right, so we've got tan beta. We're looking for RS. And we're given that SK is 2Q over sine alpha times P. Okay, so what we do is we'll just multiply by the inverse to get rid of this. Okay, and so we'll have 2Q tan beta over P sine alpha. Okay, so basically we're just going to get rid of the whole thing at the bottom by multiplying by the whole thing at the top over 1. Okay, and then those two cancel out, and you're left with just RS. And have we done what they've asked us to do? Yes, 2Q tan beta over P sine alpha. So we have proved it. You can see it's only really 2 marks. And again, it's just the correct substitution and then your final solution as well. Okay. The final question for 7.3 says, calculate the size of alpha if alpha is less than 90 degrees, RS is 70 meters, P is 80 meters, Q is 2,500 meters, and beta is 4.2. Now, we already have been given RS is equal to, 2Q tan beta over P sine alpha. So it's best a matter of substitution and then solving for alpha over here. All right. So we've been told RS is 70. 2 times Q is 2,500. Tan beta is 42 degrees. All over P is 80 sine alpha. And so we have 70 times 80 sine alpha is 5,600 sine alpha is equal to 5,000 tan 42 degrees. And now we'll just divide. So we'll have sine alpha is equal to 5,000 tan 42 over 56,000. Okay, and we can simplify that ratio first, or we can simply just chuck this all in the calculator because we're allowed to do that. Okay, and so what I'm going to do now is just grab it quickly, and we're going to say second function sine, and then we'll have a fraction, so it's 5,000 tan 42 over 5,600, and we'll just close those brackets and equals, and it gives us an angle of 53,5, and then we round off to the nearest decimal place, so for 5,1. All right, so our final answer for that one, now that it's missing, is going to be alpha is equal to 53,51 degrees. Okay, so marks 1 for substituting into the RS is equal to 2Q tan beta over P sine alpha. Okay, then 1 mark for simplifying the ratio and 1 mark for your final angle. All right, not too complicated. That's pretty straightforward. It's algebra maths. It's not crazy maths. Okay, guys, thank you so much for watching this video. Join us for our next video on question 8 and 9, which is geometry, Euclidean geometry. How fun. So take a watch, and please like and subscribe if you enjoy the videos, and share them with your friends. You never know who needs some help with maths. And if you're asking that question, your friend is probably asking the same question too. Cheers for now.